R2.11 is on functions, domain, and range. The first definitions of a relation. A relation is a correspondence between a set of independent values called the domain and a set of dependent values called the range. So the domain, since it's our independent values, is going to be our x's. The range, since it's our dependent values, is going to be our y's. Okay. Find the domain and range of each of the following relations. All right. There are two different notations I can use for domain and range in these. The first is going to be set notation. And if I have a finite number, I'm going to use those squiggly brackets that you can see printed here. I'm going to list in numeric order all the x's. So -2, then 0, then 2, then 3. Those are all the x values. Then my range, in again numeric order, is going to be -1, 3, and 4. If -1 gets repeated, you don't use it twice in the range, it's just in there once. You just want to list the distinct values that get included in the range. Okay. Now, I use this set notation when they are discrete, which means they have a finite number of values. Those values, those 4 values, or those 3 values, and no more, no less. That's the same thing that's going to happen over here. The domain is x values, so -3, 2, and 3. And the range, set of all y values that are 0, 6, 12, and 18. Okay. C and D are also going to be discrete, so I can give my domain as a set of all x values, looks like -5, -2, 0, 1, and 4. I don't have so much room right here, but that's one set. And then the range, there's only one value. It still gets to be in the squiggly brackets. Those are the set notation brackets, but it's just range is the set of 3. And the last one that's discrete, the inputs are the domain. So A, B, C, the elements in the domain. And the elements in the range are 1, 2, and 3. Okay. Now, in part E, these are not going to be discrete anymore. They're going to be continuous. When they're continuous, I can't possibly list all the values because there are infinitely many, even between 0 and 1, because you have 0, 0.1, 0.2, 0.22, 0.25. You can imagine so many numbers between 0 and 1 that you can't list them all. So we need to use an interval. So my domain is going to be the interval from smallest x value of -4, comma largest x value of 4. We know that we can do closed brackets or open brackets depending on if we're included or not. Those have closed circles, so they're included, so square brackets. And then the range, lowest value, remember you're not always using your ordered pair. My ordered pair gave me right here the left and the right, but my upper and lower are going to be defined somewhere else. So my range, lowest value is at -2, highest value is at 4, and brackets again. Okay, let's practice that again over here. So domain, leftmost, rightmost. So the domain is going to go from -4, bracket, to 5, bracket, and the range is going from -4 to 4 this time. Oops, wrong color. So bracket, -4 to 4. All right. Backside, the definition of a function. So those ones on the previous page, we can talk about domain and range for any relation, but not all relations are functions. In order to be a function, each element of the domain has to correspond to exactly one member of the range. If you have a graph, we often use the vertical line test. The relation is a function if and only if every vertical line intersects the graph at most once, or at most one time. If it intersects twice, it's not a function, but once or no times, then it would be. Okay, determine if the following are functions or not. So we can't use the vertical line test unless we have a picture, so I'll have to wait for that until E and F. Instead, I need to use the definition. Does it correspond, each member of the domain corresponds to exactly one member of the range? So I look, -3 gets to 2, 1 gets to, oh, that one doesn't, right? 1 maps here to -2, and 1 maps to 3. So we're going to say this one is not a function. Reason is that 1 does not have unique output. Needs to have exactly one output, but it has more than one. It has 2. Okay. In part B, A does not have unique output. It has 2 different. That's not a function either. Same reason. Because A does not have unique output. If I'm looking at letter C, each of the domain values maps to only one possibility. -3 goes to 2, 0 goes to 3. It can't go to something else, so this one is a function. Reason, every X, short for domain, has exactly one Y, or every input has exactly one output, every X has exactly one Y. And part D, this one's not going to be a function because 1 maps to 5 and 1 maps to 10, so that's no good. Not a function. Because 1 does not have unique output. All right. Parts E and F. Okay, these are graphs, so I get to use the vertical line test. If a vertical line hits one or fewer times, it is a function. If it hits more than one time, not a function. No vertical line that I could possibly draw would hit this graph in more than one place, so this one is a function because it passes the vertical line test, whereas this one is not a function because this vertical line, for instance, hits it 2 times. So this one is not a function because it fails the vertical line test. Okay, a couple more graphs on the next page. Determine if the following are functions or not. Okay, I've got a graph here. This one, if I draw vertical lines through it, no chance of those vertical lines hitting twice, so this one is a function. And again, it passes the vertical line test. Part B, if I draw a vertical line through the vertical line, it's definitely going to hit it more than once, so that one's not a function. Vertical lines themselves are not a function. Not a function. Because it fails the vertical line test. Okay. I can't see these, so I need to answer them based on what I know about their shape. Y equals, I know it's a line, I know it's a diagonal line, so it is a function. Any function is going to pass the vertical line test. Any line, I meant to say, any line is going to pass the vertical line test unless it's vertical. This is a function because it's a diagonal line. Okay, this one isn't solved for y, but I know I could solve for y, and it would look like this if I did. This one is also a function. Same reason, it's a diagonal line. Y equals a number is horizontal, so that's a function. X equals a number is vertical, so that's definitely not a function. Like we saw in that picture, vertical lines are not functions. Okay. Note, all diagonal and horizontal lines are functions. All vertical lines are not functions. What about if it's not a line but a different shape? So I've got a parabola here. This one is a function. Reason is that it passes the vertical line test. But if that parabola becomes sideways, now it's going to fail the vertical line test. And if you look at the equations, you can see that the one that passes the vertical line test has x squared. The one that fails the vertical line test has y squared. In general, if y is ever raised to an even power, it is not a function. There's two words here. It is not a function. All right. Even power on x is okay, but not on y. If y has an even power, it's not a function.